Okay, so for today, we're going to look at basic function operations. So we're going to, first of all, just focus on g of x and f of x. Those are going to be our two functions that we're going to use in our examples. If I'm asking you to find f plus g of x, it's right here, that really means take the function f of x. Since this operation here is addition, we're going to add it to g of x, whatever it happens to be. So we're going to take those two functions, we're just going to add them. All that really means is we're going to combine like terms. Similarly, for the second one, the difference, here we have f minus g of x. That means take f of x, whatever that function is, minus whatever the function of g of x is. The tricky thing here is since this is minus, you have to distribute that negative to whatever's in here as many terms as in there's as many times as you have to distribute that negative. So that's really the tricky thing there. And then once you distribute that, all you have to do is combine like terms again. When we move to a product, so f times, there's your multiplication symbol, times g of x, that means take f of x and multiply it by whatever g of x is. Sometimes that's just an easy distribution, and other times you have to box it, or FOIL it, double distribute, whatever you want to call it. The quotient tends to be the favorite. If you take f divided by g of x, that means take f of x and divide it by whatever g of x is. Keep in mind that g of x can't equal 0 because we're not allowed to divide by 0. A lot of times for your quotient, you're going to make that fraction, and then they're going to give you a number to plug in. But we'll do an example like that. And again, this just reiterates what we just said. So looking here, adding and subtracting functions, this is nothing more than combining like terms. So for the question on the left, we're asked to find f plus g of x. What that really means is we're taking f of x plus whatever g of x is. So if we look up here, f of x is this right here. So I'm going to start with 3x plus 8. Plus whatever g of x is. In this case, g of x is 2x minus 12. Sometimes you'll see people put these in parentheses because it makes it easier for them to see what they've done. That's okay. But since here we have an operation in the middle, that's addition. Anytime you have addition, all I'm asking you to do is combine like terms. So looking here, I have like terms of 2x and 3x. 2x plus 3x is 5x. And then 8 minus 12 is negative 4. So here my final answer for f plus g of x would be 5x minus 4. The second question here, we're taking f minus g of x. That means take f of x minus g of x. The tricky thing here is whatever comes first has to come first. So I have to write f of x first, so I have to write the 3x plus 8 first. Then my sign is subtraction, and I'm subtracting whatever g of x is, in this case, 2x minus 12. The biggest mistake I've seen in the past is forgetting that you have to distribute that negative right here. So we're distributing it in, changing both the signs. So now I have a negative 2x and a positive 12, and I can add my like terms together. So here are like terms. 3x minus 2x is 1x, or just x. And 8 plus 12 is positive 20. So f minus g of x equals x plus 20. Questions on these two? Moving on to multiplication and division. So here on the left, we are being asked to multiply f times g of x. That really means we're taking f of x times g of x. So f of x is x squared minus 1, and g of x is x plus 1. If I ask you to multiply these two terms together, you're going to either have to FOIL it or box it. I don't care which you do. I'm just going to set up a box real fast. So x squared minus 1 times x plus 1. And then multiply your corresponding parts. So x times x squared is x to the third. Negative 1 times x is negative x, or negative 1x. 1 times x squared is x squared, or 1x squared. And 1 times negative 1 is negative 1. So when I go to write my answer, I actually don't have any like terms. My answer is going to be x to the third plus x squared minus x minus 1. So none of those four terms are like terms. I can't combine any of them, so I just write them in descending order. Questions on that one? Right. For our quotient, we're taking f divided by g of x. That really means we're taking f of x divided by g of x. So f of x is x squared minus 1 divided by x plus 1. A lot of times you will see problems that say f divided by g of some number. Let's just say 4. So here's another example. So a lot of times, and I believe it's this way on your test, they're going to give you a quotient because normally this would be your answer. It's not much work. So they tell you take and find the quotient and then plug in negative 4. So we would just go back to this right here and we would plug in 4. So if I simplify this, I would have 4 squared minus 1 divided by 4 plus 1. Let's see, 4 squared is 16, minus 1 is 15, divided by 4 plus 1, which is 5. So you're going to end up with a numerical answer, in this case, 3.
You need to make it not that easy.
No. So just be warned, I know the question is like this on your test. They're going to ask you to find the quotient, and then they're going to give you a number to plug in. So in this case, we just did an example, f divided by g of 4. Plug that 4 into whatever your quotient is and simplify to get your answer. Yes, you can do that too. You're good. I knew you would. As soon as I saw it, and I was like, you're good. That does simplify, yes. Making things a little bit more challenging. Now we're going to look at composite functions. So a composite function g with function f is written as, notice, maybe. Now this little circle, or this dot, is open. It's like an open circle. That is not multiplication. That is a composition. So anytime you see an open circle, that means you're going to use what I say fancy substitution. That means you're going to take and you're going to substitute whatever function is closest to x gets plugged into the function that's the furthest out. So if I give you a number, you're going to evaluate the inner function first, use your answer to plug in as the input of the outer function. So basically you're just putting one function into the other with fancy substitution. Let's practice. So here we're given f of x equals x minus 2 and g of x equals x squared. We're asked to find g of f of x. So remember, f is closest to x, so it's the innermost function. That means we're taking this f of x and we're substituting it into g. So if I go to f of x, I'm taking this right here and I'm substituting it in right here for x. So really I have g of f of x equals, and instead of x squared, I'm taking that x out and I'm replacing it with f of x, which is x minus 2, and then the squared comes down. Well, to simplify this, x minus 2 squared means I have to take x minus 2 times x minus 2. So this is going to equal x squared minus 4x plus 4. And then on the right side, we're asked to do the opposite. We're asked to take f of g of x. So now g of x is on the inside, so we're plugging that into f. So we're taking this right here, and we're taking this x out and replacing it with that x squared. So f of g of x is going to equal, I'm taking the x out, replacing it with x squared, minus 2 comes down. I can't simplify anything on this, so this is my final answer. X squared minus 2. Notice we found two compositions with the exact same functions and we got two different answers. So order definitely matters on this. So one of them we plugged f into g, the other one we plugged g into f, two completely different answers. Let's try another one. So here we were given two new functions, f of x equals x minus 7 and g of x equals x squared plus 7. For the one on the left, we're asked to find g of f of x. That means take f of x and plug it into g. So here's my f of x. I'm plugging it in right here for this x, and that x is going away. So in parentheses, I have x minus 7 still being squared. The plus 7 comes down. So the squared plus 7 comes down. We took the x out when we replaced it with the x minus 7. To simplify this, I've got to figure out what x minus 7 squared is. That means I'm going to take x minus 7 times x minus 7. So when I fill out my box, x times x is x squared, negative 7 times x is negative 7x, negative 7 times x is negative 7x again, and then negative 7 times negative 7 is positive 49. So this highlighted section actually becomes x squared minus 14x plus 49, and then this plus 7 comes down. You have one last thing you need to do to get your final answer. You have like terms right here. So final answer, x squared minus 14x plus 56. So all we did for that last step is combine the 49 and the positive 7. Take a minute and see if you can find f of g of x. That means you're plugging in the opposite direction. G is closest to x, so this is getting plugged in right here for x. So for this one, you should have had x squared plus 7 minus 7. Well, your +7 and your -7 are going to cancel with each other, leaving you with just x squared as your final answer. And again, we found the composition both ways. They are equal to two completely different things. You can't say that the same answer applies to both. So you've got to find them both individually if that's what you're asking. And then one that tends to trick students. So here we're asked to find f of x. So here we're asked to plug f of x into f. Only gave us one function. So sometimes it helps my students to go ahead and write this function 2 times. And then you're going to take one of the f of x's and plug it into the other one. They're exactly the same, but you're still taking one and plugging it into the other. So if I plug in, I have x plus 2 plus 2. Well, x plus 2 plus 2 is actually x plus 4. Questions on this one? I believe on the next page you have some circled problems to work on. If you have questions, let me know. There is a question number 12 on the back. Is that quotient I told you about? You're taking g divided by h, and then you're plugging in -9. So be careful of that one. You do have to do a substitution there at the end.